Hello boys and girls, and welcome to lesson 5 from chapter 1, where we're going to be looking at, let me just move this down, graph ratio tables, as you can see right there. Now what we mean by this, boys and girls, is that we're going to continue to use the ratios, and we're going to continue to use the concept of proportionality to graph on a grid, the way we've worked when we graph horizontally and then vertically. Okay, we're going to use those numbers, those ratio numbers, to graph either time and distance, or you can say distance and amount. Okay, two variables. We're going to graph them. So let's take a look at the first example on page 47. So here we have it, page 47. Let's read. The coordinate plane is formed when two perpendicular number lines intersect at their 0 points, as we see here. Two perpendicular lines intersect at their 0 points. One line and another line. Remember, it's always x first and then y. This point is called the origin. So right there, that is the origin where we begin. The horizontal number line is called the x-axis, and the vertical number line is called the y-axis. An order pair such as 2 and 3 is a pair of numbers used to locate a point on the coordinate plane. Okay? Fill in the blanks with the highlighted words from above. So we want to know what this is, what this is, what these are, and what this is. Alright, so we know that this is pointing at the y-axis. Right here we're pointing at the 0, so we know we have the origin. Over here we're pointing at the numbers and the order pair. Okay, the order pair, the coordinates. You can write the coordinates or the order pair. And down here, this line is pointing at the x-axis. And the entire thing, we title it the coordinate plane. And there you have it. You can pause now and copy it down, or you might have been copying it as we were reading it, which is fine too. Continuing on to the real world link. In 3 minutes, a North American wood turtle can travel about 17 yards. Wow, that's slow. If the x-axis represents minutes and the y-axis represents yards, write an order pair to represent this situation. Alright, so 3 minutes, 17 yards. The x-axis represents the minutes. So right here we have the minutes, the x-axis. It's always good to label it, so go ahead and label that. You can write minutes right there. Alright, and the y-axis represents the yards. And there you have it. Okay, so we have minutes and yards. Write an order pair to represent this situation. Okay, well we know what the pair is. We've been given right here 3 and 17. And the reason I chose 3 first is because the x-axis is always first and then the y. Now you might be noticing a mistake here that we have 17, but our y-axis only goes up to 10, doesn't it? So we actually have to, we won't be able to label it using this increment table. We have to change the increment table. So we have to change these numbers to something that will fit with 17. So perhaps each one of these could be 5, or each one of these could be 4s. An increment needs to be arranged so that these lines go all the way up to 17. Or this would be a great learning opportunity to learn this little trick. Now what we can do, boys and girls, is that we crunch this side by making a little line here like there's a squiggly line. We make a squiggly line like so, and what that means is that these numbers here between have been compressed. Okay, they've been compressed, like pressed in or crushed. So from here we can say that from here to here we have 10, and then it starts to count beyond that. Actually, I would want this to be 11, 12, 13, 14, 15, 16, 17. So it goes, this is crunching up to the number 11, we can say. Okay? and now I've changed them all to 6, 11, 12, 13, 14. So now we can work with it. But always remember that this little line just means that from 0 to 10 or 0 to 11, we've actually made it shorter because there's no numbers in here. We just care about the numbers of the coordinates up here. Okay, so we have 3, 17. 1, 2, 3, and then 17 right up to there. Okay? And this works proportionally, as you can tell, because if the turtle keeps the pace, and let's say at 4 minutes, it's going to increase at the same rate, okay? In 4 minutes and in 5 minutes, it'll continue to increase at the same rate, okay? That's why it needs to be proportional. All right, page 48. We have a table right there. Let's see what the table means. The table shows the cost in dollars to create CDs of digital photos at a photo shop. The table also shows this information as ordered pairs. Numbers of CDs, cost in dollars. Numbers of CDs, cost in dollars, and we've ordered paired them. We put them in the order so that we can graph them. We can put them on the coordinate plane. Okay, let's see. So numbers of CDs is the x-axis, as you can see right there. On the x-axis, we have numbers of CDs. On the y-axis, we have the cost in dollars. As you can see there, cost in dollars, and it's on the y-axis. Okay, so then we have 1 to 3. So if I buy one CD, it's going to cost me $3. One CD will be $3. You see that? X first and then Y. 2 CDs will be $6. 2 will cost me $6. And 3 CDs will cost me $9. 3 CDs, $9. You see that right there? This is all a proportional relationship. It's all proportional. It's increasing at the same rate, so that it's easy for us to be able to draw a straight line, and we can predict how much, okay, the next one will cost, how much further it will go. So then if we were to do 4, it would increase by another $3, so it would be 12, and our next coordinates would be 4 and 12, okay? So then that would be very easy for me to see. And because we have a coordinate plane, I can just simply continue to draw this line straight as high as it can go on a large coordinate plane, and I could always predict the price for the number of CDs. Okay, let's try the example at the bottom of the page. Okay, the table shows Gloria's earnings for 1, 2, and 3 hours. The table also lists this information as ordered pairs. So she worked 1 hour, 2 hours, and then 3 hours, and we're showing her earnings. So hours is the x-axis right here, so we should title that hours. And the y-axis, is the y-axis is dollars earned, so we should label that as well. So there you have earned dollars, okay? And they've been ordered pairs, so 1 and 5, 1 and 5, 2 and 10, 2 and 10, 3 and 15, 3 and 15. So always horizontal first and then vertical. Let's pair them up. 1 and 5. 1 and 5. Oh, there's no 5. There's a 4 and a 6, so we have to put it right in between. Okay? I had to zoom in to do that because it's really hard to write on this. So then we have 1 and 5 right in between. And then we have 2 and 10. And 3 and 15. 15 lands between 14 and 16, so the line is right in between. And you can see, boys and girls, that it is a perfectly aligned increment, okay, because they're proportional. So we graph the ordered pairs, and now we have to describe the pattern in the graph. Well, the graph shows that Gloria's earnings increased by $5 each hour. And there you have it. Let's star this one, please, as a key answer. Okay, let's continue on to page 49. For example 3, we're going to essentially be doing the same thing, except now we're doing 2 proportions, or I should say we're going to graph 2 different scales, 2 different results in one, and this helps us compare values. Okay, we get to compare 2 of them. So essentially we're just still doing 1, but we're doing the same skill but twice. Page 50. 2 friends are each saving money in their bank accounts. Marcus saves $10 each week. while David saves $15 each week. So Marcus is saving slightly less than David. So 1 week, here's Marcus, 1 week for Marcus. Okay, 1 week would be what the weeks will be on the x-axis and the money saved will be on the y-axis. So 1 week for Marcus is $10. 2 weeks, $20. 3 weeks, and so on. But for David, 1 week, each week he saves $15. So 1 week will be 15. Second week, if you know how to count by 15s, you know this is 30. Third week, 45, 60. And then just write out the coordinates, the x and the y in each one. X, y, right there. Okay, you should have this written down. I'm sure you were able to figure it out on your own quite easily. So make sure that you have this written down. And now we can graph. As you can see, we have the graph, we have the, I always do that, sorry. We have the amount saved and we have the weeks, okay? We're going to have to color coordinate these. I would say maybe assign a color for Marcus and a color for David. I'm going to make Marcus red and David blue so that we can see where they stand, okay? Their differences. And there you have it. This is how I've solved it. So we had 10 and 1 for Marcus. So we have, 1 and 10, 1 and 10. And then 220, 220. 330, 330. Okay? 440, 440. And there we go. Okay, and then for David, 115, 1 and 15. There is no 15, so we have to land between 10 and 20. So 1 and 15, 2 and 30, 3, 45, 4 and 60. Look at the difference. And the amount is the same time, it's 4 weeks, but look at the difference that only $5 a week makes. $20 at the end of it all. $20 difference. Question 3. How do the ratios of Marcus's savings and David's savings compare? How is this shown on the graph? Well, we just saw that David was able to save an additional $20 by the end of the 4 weeks because he was saving $5 more each week. So how is this shown on the graph? Well, as you can see in the previous graph picture, David's line is more vertical. It has a sharper incline, right? While Marcus's line is slower at increasing. It has a less gradual slope. This has a more sharp slope because it's going up in a shorter amount of time. If it's going up greater in a shorter amount of time, it means it's going up faster, right? It's going up faster, and that's how it's shown on the graph. This means more. At the end of 4 weeks, you can see that he has 60, while Marcus at the end of 4 weeks only has 40, and that's how it's shown on the graph. David's savings, $15 per week, increases at a higher rate than Marcus's savings, $10 per week. Both sets of points appear as straight lines because they're both proportional. David's line is steeper, which just means he's making more money at a shorter amount of time. That is a key answer. Number 4. How can graphing help solve a problem involving ratios? Well, as we just saw, a graph shows which ratio is greater when comparing two ratios, like we saw with David's earnings. We looked at 2 separate ratios and we were able to see which one was greater because the line was steeper. And this will be your last key answer, okay? And that's it for today, boys and girls.